All right, so imagine that you have a nucleus of an atom in the center of this round blown up balloon. And these little beads that you can probably see sitting at the bottom are our electrons. So this balloon is representing something called an orbital, or basically a path that these electrons are moving around and can be found 95% of the time. So it's the most likely location for those electrons at any given moment. Now, let's look at how they kind of move around this orbital. You can probably see them tracing out paths around the edge of the balloon. And this is really kind of how electrons are in actual atoms. They're moving really fast. They're moving around the edge of this orbital sphere. And they look just like that. Now let's look at a different type of orbital. That's a round or spherical orbital. We call it an s orbital. So I always say sphere s orbital. But we have other shapes too. This looks kind of like something called a p orbital. This p orbital is sort of dumbbell shaped, where it has two lobes and this kind of center area where the electrons don't go. You can just call it two balloons tied together. It doesn't really matter. So we've got electrons down in this part, and we've got electrons up here. It's a little harder to get these moving. But similarly, the electrons are moving around inside of each lobe, or each half, of that p orbital. There are other shapes of orbitals as well, but they get very complicated, and we're no longer able to represent them easily with something as simple as a balloon.